Now let's solve question 7 of this paper. So the variables x and t satisfy the following differential equation, and t is greater than or equal to 0 for all values. Now it is further given to us that x is equal to 0 and t is equal to 0. This we will use later. Let's do this step by step. So for part A, we have to solve this differential equation and obtain an expression for x in terms of t, which means that we will be turning x into our subject. So let's start. This is our differential equation. Now, the first thing we're going to do is try and get everything with x on one side and try and get everything with t on one side. So first, I'm going to send the dt to the other side. So we have this. Now, as you can see, we have e to the power 3t with dx and cos squared 2x with dt. So we need to change that. So let's take it step by step. First, we're going to send e to the other side. And now we're going to send cos squared 2x to the left-hand side. And we have this. Now we can find the integrals. So as we know from the laws of indices that if we want to change anything from numerator to denominator, the power becomes negative. So if we have this, it would become a to the power minus 3. As such, we can write our equation like this: dx and e to the power minus 3t dt. So the integral of e to the power minus 3t is very simple. We're just going to copy it as it is and divide it with the derivative of the power, which is minus 3. And as for cos to the power minus 2x, we know that 1 over cos square 2x, there is an identity, and that would be sec square 2x. So we do not need to bring the power up and write it like that. And another thing we should know already is that the integral of sec square is tan. So we will write this as the integral of sec square 2x according to our identity, and the integral of that would be tan 2x. But since we have 2x, we need to divide by the derivative of whatever is inside the tan. So that would be 2. So now we have ended up with this. So let's just rewrite that as such. And we have this. And of course, we add plus c whenever we are doing integrals. Now, we were told that x is equal to 0 and t is equal to 0. So we are going to use this information now while trying to find the value of c. So if we plug in x as 0, we get tan 0 and minus 1 over 3 e to the power 0 plus c. So this entire thing will become 0 and e to the power 0 is 1. So we're left with this, and we can find that 1 over 3 is equal to c. Now we needed to find our equation in terms of t for x. So let's rewrite our equation and then make x the subject. So far we have half tan 2x is equal to minus 1 over 3 e to the power minus 3t plus 1 over 3. Now we can factorize this and make x our subject. So we could just rewrite this as such first. Now we can factorize and take 1 over 3 common. So we end up with this. Now let's send the 2 from the half to the other side. And so we get 2 over 3 bracket 1 minus e to the power minus 3t. And now we can do tan inverse and get this minus 3t double bracket. And finally, we can divide by 2 and 1 minus e to the power minus 3t. That is our final answer in terms of t. Now, part B states what happens to the value of x when t tends to infinity. So we have this equation and we need to see what happens when t goes to infinity. So here we have e to the power of minus 3t. So if we plug in t as infinity, minus 3t would go to minus infinity. So what would happen to e to the power minus 3t? So if anyone picks up their calculator, you could check right now, and if you insert e to the power minus 3, any huge value like 99999, you would get 0. So essentially in our above equation, we need to replace e to the power minus 3t with 0. So if we do that, we get x equals to half tan inverse 2 over 3 bracket 1 minus 0, and that will give you half tan inverse just 2 over 3. And if we plug this into our calculator, the value for x comes out to be 0.294, and that is our answer for part B.